All right, good morning everyone and welcome to the Digital Learning Network. My name is Michael and I'm going to be your host today as we learn all about analog missions and what we're doing right here at the Johnson Space Center. Now I'm coming to you live from Houston, Texas at NASA's Johnson Space Center, and we're actually right here. This is an aerial view of the Johnson Space Center. We're in Building 9 called the Space Vehicle Mock-Up Facility. And here we have actual mock-ups of the International Space Station, of the Space Shuttle, of Orion spacecraft, and futuristic vehicles that we'll hopefully be using to go to asteroids and to Mars someday. So this is an amazing training facility. Right here on the right side you're seeing lots of unique facilities. For example, the multi-mission space exploration vehicle. We've got Argos, the active response gravity offload system, and we're going to be talking about all this stuff in our program today. And as you can hear, it's a live facility. There's lots of work going on right now, so occasionally you hear bumps and slams and lots of noise and everything. Yeah, some hammering too. This is going to be an amazing broadcast. Now, we're also piping this out to the internet. This is going out on our DL Info channel. And if folks watching there have any questions, please feel free to email your questions. Now, we have an active school down in Corpus Christi, the Tuloso Midway High School in Corpus Christi. So we're going to be taking questions there as well as the internet. Now, for the folks watching on the internet, here is the actual location or the site that you can email questions. It's dlinfochannel@gmail.com. And we'll be posting that up periodically so you can email questions to us during our program. So let's get right to it, to our program. We've got two very special guests with us today. Mr. James Johnson, who is actually with the Analogs program. He's an engineer and a test conductor, a coordinator. And we also have David Cohen, who's actually a RATS crew member, who was actually living in the space exploration vehicle just a few days ago. So we're going to be talking about all the amazing things that we do as part of analog missions. And I'm going to go ahead and turn it over to you. What is an analog mission? What does it mean, an analog? And what are you guys doing right now?
Yeah. Well, an analog mission is again, it's just short for analogous. I mean, it's similar to. And what we're trying to do is really two things. We're trying to understand what we call mission architecture, and that's how do you put together all the pieces of the puzzle to execute an actual space mission. And then the other piece is technology, and that's the technology demonstration. We've got a whole suite of different missions set up to really help us do that, help us understand how are we going to go ahead and operate when we get to some of these future destinations, as well as demonstrate some of the new technologies. The one we're doing right now is the RATS mission, Research and Technology Studies. We've started years ago back out in the desert and ended up slowly building up some different concepts for a return to the moon. Now we're looking at Mars, or actually we're looking at near-Earth asteroids, and eventually we'll be looking at Mars. And we've kind of migrated to here at Johnson Space Center in Building 9 to take advantage of some of the different technologies and capabilities we have here to simulate asteroid exploration.
Okay, and I actually have a video of an overview of what we're doing right here in this building, so I wanted to go ahead and go to it real quickly, and I was wondering if you could talk to it real quick about just some of the things that are going on.
Okay, so yeah, we actually did some engineering tests back in December and January, and that's exactly what this video is as we're kind of figuring out how we're going to do the test that we're doing right now. What you just saw was the multi-mission space exploration vehicle that kind of served as the main exploration platform for the crew that we're testing out. Nice, roomy, spacious interior meant for 2 crew. They are looking at design concepts for going up to about 3 crew there. This is the simulated environment, and the primary reason that we are here at Johnson Space Center. We've got some excellent experts that have put together this high-fidelity physics-based simulation where we can simulate flying around an asteroid surface. Some of the other technologies that we brought on are the suit port, as well as these mock-up suits that you see right now. The suit port enables a crew member to actually go out and do a spacewalk within 15 minutes. Right now on the space station, it takes hours to get ready before you actually go out.
Depressurization and that kind of thing.
Exactly, all the conditioning,
getting in the suit.
It's quite the workout. So the goal is to test out this technology so we can get out there that much sooner and really maximize our exploration. You mentioned we're using Argos, an active response gravity offload system. Really neat system where they put you in kind of this hang gliding harness, and then they offload your weight so that way you get similar reaction as if you were actually floating in microgravity. And of course, asteroids, the gravity field is so small. It's really a microgravity environment. We also use this air chair to kind of give the crew some familiarity with what it'd be like to fly kind of a jetpack around. We aren't using that right now. This whole cabin is mounted on a air-bearing sled, basically like a big air hockey table, so we could fly the whole cabin around. Again, that's something that we aren't doing for part of this test. We're going to be doing that a little bit more coming up in September as kind of a standalone demonstration. But those are some of the main different components that have all come together to really make up this RATS mission.
All right, it sounds really fun, really interesting. I bet you had a great time so far. You actually lived inside there for how many days?
I did. I was there for 3 days and 2 nights.
Okay, excellent. This is David Cohen. He's actual RATS crew member. He's from the EVA office and teaches astronauts how to do spacewalks. So he's bringing his expertise here to work out the techniques of how would you do spacewalks out on an asteroid, right?
Sure.
Leaving the space vehicle and then going out to an asteroid.
Yep.
Excellent. We've got lots of other stuff, and it's not just one team or a couple of people working. There's a whole group of people that actually makes this happen, isn't it?
Yes. A lot of work goes into it over. I mean, we've been planning this for basically the past year. A lot of the details really came together in the past 6 months or so. And you can see some of the operations team that we have.
Yeah, we actually have a live view
Perfect.
Of the team. They're busily on computers. They're looking at all the simulations. There are 2 people inside the MMSEV right now, the Space Exploration Vehicle. And do you know what they're doing right now?
So right now we're simulating anchored asteroid operations. That's simulating that the SEV is just anchored to the surface of an asteroid. And we actually have crew members that are out doing spacewalks. One in the virtual reality environment, and then you probably heard that hammering just a few moments ago.
Yeah,
That's over in Argos. They're actually chipping off rock samples and collecting rock samples.
That's
and then
cool.
we've got helmet, video that's being streamed live to the person that's inside the SEV right now, as well as to a simulated deep space habitat workstation. The thought is that the vehicle you see behind us would be part of that element that would actually explore the surface, but you still have kind of a mothership, so to speak.
Someplace to live, someplace to
a large volume where you can live for long duration and get to and from the asteroid or to and from Mars. We call that the deep space habitat, and we have a crew member there in a simulated workstation that's kind of serving almost as the conductor with mission control, and that's the team that you showed live just a moment ago. That's part of our real-time operations team, just collecting the data from the simulation and making sure everything runs smoothly.
We're actually still on that shot, and if the
great.
camera can pan left a little bit, I had seen this big TV monitor with tons of images, so you're able to connect all the different areas, like the virtual reality lab, the Argos, inside the cabin itself. So that's on those monitor screens right there, so you can see exactly what's going on during the entire mission.
And the other important piece here is we also have folks at mission control team over in Building 30, that's also Johnson Space Center, and they're looking at all of the data and have all the communications with our crews over a 50-second one-way time delay. So it takes 100 seconds round trip to go ahead and get a question answered. So we're exercising that, and
they're right next door to our real mission control center. So.
Oh, really?
Exactly.
And how difficult is that, doing that big of a time delay? Because when we're going to asteroids, that's millions and millions of miles away. It's not just 100,000 miles away or 250,000 miles away to the moon. It's millions of miles away.
It's challenging. Whenever we talk, where we're at locating or simulating right now, it takes 50 seconds to go each way. So it's 100 seconds round trip to say anything if you say it right away. So it can be challenging. You have to really think about what you're going to say and package it properly, get it out, and not expect a response for a while. So we're trying. Normally we do a lot of voice communication with Space Station right now, so we're looking at not only doing that, but doing some texting to help us get all the words out properly and a little quicker.
Okay, excellent. Now let's see, what else? The crew members. We've got 5 crew members as part of the team itself, and I wanted to show you a picture of them right here. Can you describe your other crew members?
Sure. Let's see. Starting at the top right, that's Trevor Graff. He's actually a planetary scientist here at JSC. He does a lot of work with the Mars rovers, even though the one currently on there. So he's in here as one of our 2 scientists. So we at a time we have 2 of us in there in the MMSEV at a time. Usually an engineer or a pilot, and then also a geologist with us. So he's here to help us keep it real. Below him is Liz Rampy. She's another geologist. So she's also a planetary scientist, working primarily on Mars type stuff. But again, here to help us understand it and help the other three crew members speak a little more geology too. They do a lot of explaining to us and helping us navigate around the asteroid. To her right is Allison Bullinger. She's an engineer. Like me, she's a spacewalk instructor and flight controller, so her and I have a very similar background. So she's here to help us understand what we can actually do out on a spacewalk and how we might do an EVA or a spacewalk on an asteroid that's not really set up for that. Next to her is Mark Reagan. He's actually a Capcom, so he's one of the people who sits in mission control.
Oh, the International Space Station control room, and
yes.
he's the one that's the liaison between the ground crew and the crew out in
That's right.
space.
Yep. He talks to them a lot, and but he also works analog missions. So yeah, he has kind of two jobs also.
Okay.
So he's here as our fifth crew member, helping us out, and then I'm the one above Allison. So like you said, I work over in the spacewalk instructor and flight control area, and I also work over in the spacewalk office. We're developing future hardware and architecture for spacewalks on various destinations.
Okay. And before I get too far into it, each individual locations where you're actually doing these analog tests, I wanted to go out to Tuloso Midway High School to see if you have any initial questions about what we've talked about so far. We are going to jump into each individual area, but I did want to see if you guys have any initial questions about what it takes to conduct these tests, or about the things that we're doing here at the Johnson Space Center.
What it was like to live in the cabin for
Yeah,
3 days.
yeah.
And
Any questions so far? Yeah, definitely come up to the microphone and speak loudly and clearly.
How did those mobile suits work? Behind you.
Oh, I think, yeah, the question was on the suits. Actually, Dave was in it just the other day.
Yeah, they have. And this is a sort of a mock-up of one, so it's not, you can't actually pressurize it, but yeah, you can see that. They work quite a bit different from our current suits we use on Space Station. Right now on Space Station we have a suit that we put the pants and boots and the shirt on, basically the upper torso and the helmet all separately. This suit we kind of leave assembled, as you see, and attached to the back end of the MMSEV. And where it's attached is what we call a suit port, and it has a hatch in the back. And that hatch allows access inside and outside the MMSEV. So when we're inside, we can actually open the inner hatch, and we can climb into the suit from inside and close the hatch behind us, and then release ourselves from the suit port there and go do our spacewalk.
And it's actually kind of neat. I'm sure you've seen some of the pictures of lunar exploration when we had astronauts on the surface of the moon, and they came back just covered in dust.
Right. Yeah,
and
fine particles of the lunar regolith.
Right,
yeah.
right. And the thing is, when they came back in, they're breathing all of that stuff, right? So this concept is actually you leave that outside, climb into your suit, you do your exploration, you come back in, and the suit's still outside.
That is awesome. That is great.
Great design.
And do you have a storage area, like maybe where you're going to put all the rocks and samples that you collect during the spacewalk?
We do actually.
That EVA compartment?
Right, this suit's actually facing our rock box, so where we're going to store all the
rock
rocks. So we collect them outside during a spacewalk in the suit, put them in the box, and then back up to the suit port, attach ourselves in, and climb back to the back.
Okay, excellent. Great question. Got another one there at the high school? Nope, not yet. Well, if you guys think of any, feel free to raise your hand once we do questions. I don't see any from the viewers on the internet yet, but we'll be checking it periodically throughout our program. And it looks like we got another class in. Welcome, everybody. We're learning about analog missions and what it takes to work out the details of how we're actually going to journey beyond low Earth orbit and explore our solar system. All right, now we're talking about the crew members, and since we got a bunch of new people coming in, let me go ahead and do a quick video about the crew members, just as an overview of their backgrounds and what they're doing here on this analog mission. So let me go ahead and start this one real quick.
Hi, I'm David Cohen. I'm one of the RATS 2012 crew members. I work here at NASA's Johnson Space Center as a spacewalk officer, where I train astronauts to do spacewalks and also direct those spacewalks for mission control. On top of that, I work on future spacewalk tools and techniques. And as such, I'm involved in a lot of these analog missions like RATS and like NEMO missions that we do underwater at Aquarius. I've worked on several previous RATS missions and a couple previous NEMO missions, and very happy to support this year as a RATS crew member.
Hi, I'm Liz Rampy, and I'm a geologist at Johnson Space Center. I study Mars. More specifically, I study the minerals that form from water-rock interactions and what those minerals can tell us about past aqueous environments, like the pH, the temperature, how much water there was, and whether or not ultimately that surface was habitable. I've been on the science team for RATS in 2010 and 2011, and I'm really excited to be a crew member this year for Desert RATS 2012.
Hi, I'm Trevor Graff, a planetary geologist here at the NASA Johnson Space Center. I'm supporting the RATS testing 2012 as a primary crew member, and excited about exploring an asteroid this year.
Hi, my name is Allison Bollinger, and I'm a crew member this year for RATS 2012. This is my first year helping out with the RATS analog, so I'm very excited about taking the integral role of being a crew member this year. When I'm not working on RATS, I work in the Extravehicular Activities Office, where we train crew members in all aspects of spacewalking, including how to use tools and how to use their spacesuit, the EMU. And another part of my job is to also work as a flight controller and mission control when the crew members are performing spacewalks.
Hi, I'm Mark Reagan. I'm one of the RATS 2012 crew members this year. I work in the Analog Projects Office here at the Johnson Space Center, and we are looking at the problem this year of how one would explore a near-Earth asteroid. And it's actually part of a series of analog missions we've done this year. Earlier we did a NEMO mission, which is looking at this problem under the sea. This RATS 2012 mission is looking at this problem with some of the advanced facilities and simulation techniques that we have. And between the two, we are hoping to piece together a comprehensive look at the tools and techniques and ops concepts required to explore a near-Earth asteroid. It's going to be fun. I'm looking forward to it.
All right, so we got a great crew. It's actually part of RATS 2012, and they're doing work right now, like David Cohen, an EVA specialist or spacewalk specialist teaching astronauts how to do spacewalks. He's giving his insight on how to actually do the process or procedures for doing spacewalks on an asteroid as part of our analog program. All right, now we're going to go on and talk about the individual components of the vehicles and the machines and facilities that we actually have right here at the Johnson Space Center. So our first stop is going to be the Multi-Mission Space Exploration Vehicle. Ooh, that's a mouthful. What do you guys call it? Just SCV for short?
You know what? When I'm on the comm systems, yeah, I can call it SCV.
Okay.
Just easier for me to say.
Yeah, it's the interesting thing about it is it's one of a series of generations of this vehicle. We use these analog tests to really help inform how we design things. And the very first version of this vehicle, you may see some pictures on the internet, factoring Desert RATS, and it's got a big forward kind of bulb-looking window on it. And this is the second generation.
Okay.
So what we did is we took the first one out, we tested it out, we learned something about it, and that was
so the first one
result.
actually set on the Lunar Electric Rover, or the Chariot, or
Right.
a mobile vehicle, like a rover that would
It was
go
mainly a rover.
Okay, excellent.
To
Now
drive around.
they're getting a little bigger and a little bigger. Is that correct?
Little
control
bigger in
systems?
size, not much
Not
though.
too much bigger in size,
Okay.
yeah.
Yeah.
Just different control systems, yeah. Instead of driving on the ground, we put a free-flying system we can fly it around in space.
Okay.
Hence the multi-missions. Now, this cabin can both drive on the ground or fly around in space.
Okay, and I do have a video of it in action. I wanted you guys to talk about that as well, because you actually got to control it inside. So let me go ahead and go to that one. So what was it like to maneuver? Did it feel like you were truly out in space?
Oh, it did really, yeah. They have the simulation built up to where it reacts just like it would in a microgravity environment, so with no gravity. So we have a control stick there where you can fly it kind of like you would a video game. You can see out the front windows there. Those are actually monitors in front of the windows. So those are real windows. I'm looking at a monitor in front of me, and they project the simulation up on those monitors, and we fly it around, and you can see the rocks through the windows there. So we have our standard control system. We can drive in and out, up and down, left and right, and we can roll, pitch, and yaw it. kind of like you would almost a video game flying around
Okay.
space.
So what were you using the tablet for?
The tablet we're mainly using for navigation purposes. So that has our timelines, basically our schedule for the day, what we're doing, where we're going. It has all of our maps on it. So I pull up the current map of because there's several places on the asteroid we might want to go to. So there's maps, there's high detailed maps of each one of them.
Okay.
So I'd pull up the location that I'm flying near, and I would use that and hold it up to the window to help me navigate. So
Oh,
you're
that's
trying
cool.
to match the rocks on the surface with the rocks in your map, so you know exactly which rock that the scientists on the ground want you to go pick up.
You also have monitors of other people doing in the Argos facility.
That's right.
Like
yes.
they're spacewalkers on the asteroid collecting samples.
Yeah, these blue monitors, these blue ones in front of us, those have all of our navigation equipment on it, our control systems. But we can also pull up camera views of what is happening with the spacewalk person. So that person may be in the virtual reality lab, themselves flying a jetpack around the asteroid, or they may be on Argos and actually physically handling hardware and hammering, like we heard a little bit earlier.
Wow, that is amazing that you can tie all that stuff together and actually do a full simulation of a mission right here in this building.
And once they get it up and going, it feels really, really real. You're immersed in it, and you seem like you're there.
Yeah, it's got 8 windows all around. They're all tied in together, showing the exact same thing. So you're actually moving around like that rotational view. That was amazing. Did it give you a little vertigo?
Almost, it could. I think if you flew it fast
enough. You did fast enough, yeah. So it's just an amazing facility, the multi-mission space exploration vehicle. All right, excellent.
Good video.
Yeah. And once again, for those of you that are joining on the webcast, you can definitely send us questions. We would love to hear from you guys. We're going to have a question and answer period at the end of our program, and we'd love to hear from you. Once again, that address is dlinfochannel@gmail.com. And so submit your questions there, and we can answer them on the air. All right, now we're going to talk about other parts of the facility itself. Remember we mentioned Argos. What does Argos stand for again?
This is a test, right?
Yes, it
Active
is.
Response Gravity Offload System.
Excellent, yeah.
Yep.
Definitely a mouthful, so that, as you can see, we love to use acronyms here at NASA. So, Active Response Gravity Offload System. Basically, it's a sophisticated kind of bungee system that actually takes away the weight of gravity, so you feel like you're floating in microgravity?
Yep, you're in a harness, and the one reason today is actually a paraglider harness, and they suspend you from a cable, and they have an active motor on that cable, and it can react to, it measures very, very fine movements in the cable and forces on the cable. So whenever you push, and then here you are suspended in it. Whenever you push off a little bit, the computer reads that force, and it'll actually pull you up with the same response you would get in a zero gravity environment. And it's on a big rectangle also, and it can move side to side and in and out. So if you push one way, it'll start sliding that way until you stop yourself. So the active motors push and pull you to make it seem like you're in zero gravity.
And you can move in many different axes, can't you?
Yes.
Because right here, you're on top of the vehicle. Let's go back to the previous one. Remember you were talking about this pressurized module on the rover?
Version. Yeah, the first version of the space exploration vehicle is what you see back behind there. So we're making steady progress, and the goal is the third one. We'd actually hopefully get to fly.
Okay, excellent.
But you can see all of our rocks in our boxes here where we do our actual physical sampling. As an EVA or spacewalk officer, I really like this because I'm physically there holding spacewalk tools, actually hammering on rocks, collecting things.
Let's see if we got a live view. We might have some obstructed views, but let me see if we can go over to a live view and see if we can see Argos. As you can see, it's a huge pulley system, big frame architecture to support all the weight of people on the bungee cords. I mean, sorry, not bungees. What's the sophisticated term for it?
It's an actual a cable with an active electric motor to it. But you can, Liz is out, and you can actually see her.
How is she?
She's out doing her spacewalk right now. She's just to the left.
Yeah, just on the left edge of the screen, I think.
All right, we'll do a pan across so you can see the whole facility. And we got mock-up platforms for different geological features, different rocks and boulders, and there's also finer material on the floor, isn't there? Let's go back to the actual image of it. Down on the bottom, you've got fine grain material. Is there rocks and sand and pebbles?
That's right, yeah. In some of this, we have some sand and some cork to kind of simulate some coarser soil, but basically when we go to an asteroid, asteroids aren't just rocks. They're also very, very fine particles. So what would just seem like dirt. And so part of the thing when we go there is to collect not just big chunks of rocks, but some of that soil, some of that dirt.
Okay.
And show it. So we practice collecting all of that.
So there might be enough gravity on some of those asteroids to actually keep those finer particles connected to the actual asteroid itself?
It's very, very low gravity. So if you picked up a rock and let it go, it would seem like it's just floating there for a minute. But if you watched it for several minutes, it'll float back down to the surface. So it's just enough to hold all this stuff together, as long as you don't disturb it too much.
That must be incredibly hard to actually do work and stuff when you're not dealing with gravity that much at all, and any movement you do will move you in an opposite direction, wouldn't it?
Yeah, and it's probably the most challenging place we can go do work out in space. So if we're on a space station that's in zero gravity environment, we design it to where you can have handholds on it, you can grab onto, you have ways to attach yourself to it, so you're always somewhat stable. If you're on the moon or Mars, you have gravity, so you can walk around kind of like normal. I mean, it's much less weight, but pretty much normal. But on an asteroid, we don't have any of those benefits. So no gravity, so you can't walk, no handholds to hold on to, so it makes it very challenging trying to figure out how you're going to do anything. And that's one of the big things we're trying to figure out here is what tools we need to attach ourselves, dig into, or what can we collect without attaching ourselves. Those kind of questions we're hoping to answer with rats.
Okay, excellent. Now, there's also other facilities here. We do robotics here. We've got virtual reality laboratories. And you actually, did you get to do the virtual reality portion of it? Okay.
Yes, yeah, I did.
Excellent. Let's talk about that lab now, because I got some pictures that I wanted to show you of different areas around site. And you can actually put on a headset. And what do the gloves do? How does that actually mimic what you're seeing in your screen and manipulate?
So this immerses you in a virtual reality environment. So you are, when you look in the simulation, you see yourself as an animated character, basically. So these big goggles on front are what you use to view it, and those goggles have motion sensors in them. So when you look up, you can look up in the simulation, left and right. And the gloves actually control your hands. So you can move your arms around and open and close your hands, and you can see it in the simulation doing that. So we use that to reach out and grab rocks or grab structure or whatever we're holding on to. And this is actually a picture of Allison in the VR system, and she's holding on to the controller for her jetpack.
Oh, okay.
So she's
kind of like a safer unit.
Yes.
Simplified aid for EVA rescue.
There you go. There you go.
That's that one.
Excellent. And is this maybe some of the images that you might see? This is like a God view, way out back from you.
Yeah, this is what the guys running the simulation will see. So you see the MMSEV right there, and you can kind of tell on the front of it we have basically a pole sticking off with a foot platform on it, and you can the spacewalk person can wedge their feet in that and basically be stable in the front of the vehicle. So the pilot of the vehicle can fly the EVA or the spacewalk person around to collect samples and give them kind of a stable platform to work off of.
Are they similar to the portable foot restraints that astronauts use for the space station?
Yes, it'll be something just like that. So you can lock your feet in, click your heels in, and be solid. So yeah, it'll be something just like we use on station.
Any robotic arms in the front or anything?
Right now, the concept is it'll possibly be a robotic arm. We're still working off whether that's it's feasible, whether it's worth doing. But for this simulation, we're just kind of using it as a stationary, straight arm. But possibly in the future, get one where we can move around a little bit.
Excellent. And I got one more just to show you. There's actually 2 chairs there, so you can actually have 2 spacewalking astronauts training at the same time.
Yep, and we did that yesterday. So we had a pilot in the MMSEV. We had one of our spacewalkers on that foot restraint, stable on the front of the SEV. So the pilot was flying that person down, and then we had another person flying jetpack around.
All right, excellent. So we talked about lots of things that are going on here right now. And how long is the mission? 10 days? 14 days?
10 days,
okay.
Yeah. We got a couple other days.
We can stop.
Yeah, until I say we're done, right? 10 actual days are where we're collecting all this data. So, we've got data on every time the crew is touching one of the hand controllers and moving the vehicle around. We end up collecting information that tells us, how much propellant would they actually use to go ahead and explore the asteroid surface. So, it's important to know that, so that way we can go back and tell the folks that are designing the whole mission, how much mass they got to get up into orbit in order to support this mission. And ultimately, that comes down to cost. So we get to help estimate even cost of these missions. So.
Something just popped in my mind. Any word or talk about utilizing the International Space Station as a way to stage things before going off and leaving low Earth orbit, instead of just launching them off and going straight there?
Yeah, definitely. Actually, is part of the analog missions that we've got. We have one analog mission called ISTAR, another acronym there.
Of course.
Yeah, it's the ISS, or International Space Station Testbed for Analog Research.
Okay.
And the thought, I practice a few, right? So the thought is that we can actually start using the space station to kind of test out some of these concepts. Ultimately, further down the road, we may use ISS as a staging place where these vehicles come up to ISS, maybe to pick up supplies or crew, and then eventually transit to maybe another smaller station or waypoint, and from there they can go off and explore the whole solar system. That's kind of like our ultimate plan. What we really want to do is posture ourselves where we can go anywhere. And it's just really up to folks' creativity and imagination and the technical ability that we were able to pull together to explore wherever.
And you're starting it all right here.
Right here, yeah. This is putting together that concept, thinking how can we do this? How can we make it work? Let's test it out, learn a little bit, go back to the drawing board, work on our designs a little bit, and share that knowledge and information.
All right, excellent. All right, now we've talked about tons of information. Now I want to turn it over to you guys. I want to hear some questions from you guys about all the stuff that we've been talking about today, or just something you've been interested about NASA or about our missions. I know we got a lot of rocket folks in there. Is this part of the rocket team? All right, excellent. So hopefully we got some future aerospace engineers, right? Okay, excellent. So what questions do you guys have?
What is the importance of collecting the asteroids?
I believe the question is, what was the importance of collecting asteroid samples?
Yes.
Yeah. All right. Well, there's several reasons that we're looking into going to an asteroid. One is actually the planetary defense argument too. We got to understand what are they made out of, and how can we go ahead and collect them and move them if needed. We're still learning that some of these asteroids are very loosely held together, and if you impact them, you'll end up with large clouds of debris. Others are very solid, in just one big homogeneous conglomeration. So really, it's to learn about their makeup and their composition, partly to understand kind of where are we from? How did some of these planets form? The thought is that sometimes these asteroids and other loose materials have coalesced over billions of years to form the planet. So it tells us a little bit about ourselves. Also tells us a little bit about planetary defense. We know that Earth's been hit by them before. They're going to get hit. We'll be hit by them in the future. So the more we can learn about them, the better. It also, lastly, presents a lot of technical challenges for us. It's not easy. It's very hard. And whenever we stretch ourselves to go to a destination that's so difficult, we learn a lot, and that gives us capability to go to many, many other places.
And you create new technology in the process, and that in turn helps everyone here on Earth.
Yeah.
Think about if we didn't go to the moon, all the technology that we created for that has actually helped. All the satellites we have today, the mobile communications that we use every single day. It's definitely a benefit from what we're doing right here.
It is the innovation piece. It is the stretching your mind to think differently, think outside of the box, and then take what you learn there and find all the different ways to apply it. That's the one thing that I think is most exciting about NASA and the companies that we do work with is come up with great ideas, and then we find ways to apply them.
And one of the most interesting things that the planetary scientists that are with us will tell you that the stuff we'll see in the asteroids is from the beginning of the universe. This is pristine stuff that is as old as anything possible. So it's kind of interesting from a science perspective and studying just where we live in the universe to see something like that.
Okay. All right. Okay, next question.
When are you expecting to actually land on an asteroid?
What's the timeline?
Well, right now we're targeting the 2025 time frame, and I use the term time frame because that's probably the soonest that we would actually be able to conduct that kind of a mission. So that's what we're looking at.
Okay. Excellent. Any other questions? And I'm getting a little feedback from the high school. If we do the same thing we did last time, and it actually worked great.
Yes, I got it.
Okay.
Is it modular enough to fit in Orion?
modular enough to fit in Orion? Do you want to answer?
The vehicle itself, the MMSEV. No, it would be a separate vehicle. So we'd have the Orion capsule. That's what the crew would launch in, and the crew would go up and rendezvous with the Deep Space Hab somewhere, maybe in low Earth orbit or somewhere around the moon or another point. And the Deep Space Hab would be basically the mothership and the main house for the entire journey, which could take weeks to months to do. Attached to the Deep Space Hab would be the MMSEV. So these would be our little excursion vehicles. And they're probably roughly, volume-wise, actually Orion might be a little smaller on the inside than these things. So.
But you can see kind of behind us the hatchway, that you have. So you have that hatchway to go ahead and go between the Deep Space Hab and Orion and other space vehicles. So the thought is that it's modular in the concept that you can bring up this vehicle and other vehicles, and we have some standards, like standard hatch sizes, to be able to go ahead and translate and transfer between vehicles. So.
And how many people are in there right now?
Two. Yeah, two's who we have in there.
All right. Excellent. Next question. No other questions?
Launch vehicle will have to be designed. Most of these guys are going to head off to college and then look for jobs. Besides NASA, what contractors are there? The whole video game industry looks like a lot of fun to these guys, but you're doing it every day for more than just a game. So who would they look for employment to do those things?
Exactly. Well, we work with a lot of different companies to go ahead and make this happen. A lot of engineering companies. Jacobs Engineering is definitely one of our major contractors.
I actually work for United Space Alliance, which is a joint venture between Boeing and Lockheed Martin. They formed United Space Alliance to do the operations of the space shuttle and space station. So they're contractors. Actually, those are three companies you can work for.
Yeah, we have some folks here with Wiley Laboratories. They're doing a lot of the analysis of human factors living inside the cabin and trying to understand the human factors aspect. So that's another contractor that we work with. In years past, working in mission control, I know we've worked with folks in Barrios Technologies. That's another group. So there are a lot of companies out here that get involved, and we all kind of come together under the common goal of conducting one of these missions.
That's one of the amazing things that a lot of people don't realize, that it's not just astronauts and engineers that work at NASA. There's a whole host of people, from the medical fields to lawyers and accountants. There are so many different opportunities at the 10 major NASA centers and minor centers around the United States that just do what you love, what you're passionate about. If it is aerospace engineering, that is absolutely wonderful, because we do need engineers as well. But almost any field you can think of, we actually have here. Planetary geologists, right here, right in the mission, in the MMSEV. So study what you love, be passionate about it, and if you love to do it, your job's going to be a breeze. It's going to be so much fun. Did you have fun as part of your first half of the analog mission?
That was great living there. And flying around, doing all that. So yeah, absolutely.
Excellent. Any more there?
I'll ask. Any thoughts on where you're going to park the deep space station?
The deep space habitat?
Right.
The goal is that we would be able to actually dock it to a propulsion module, and then we could put it wherever we want. Some thoughts are that it would you'd probably stage it and do some assembly maybe in low Earth orbit. There are different Lagrangian points in what we call kind of cislunar space, and that's those are good places to go ahead and bring different components together. Eventually, hopefully we can park it off the lunar surface. We could park it off of the Mars surface, in orbit around them. So there's really a whole bunch of different options that are available. Once we dock it to a propulsion module, we could just move it from one location to the next. For this scenario that we're doing right now with the asteroid exploration, we're simulating that Deep Space Hab is parked about 100 kilometers away, and what we're saying is kind of station keeping mode. So it's not really in orbit, but just kind of hovering about 100 kilometers away from the asteroid surface.
to keep your main home safely away from the asteroid, and that's why you have one of these. You can fly it down to the asteroid, be a little safer, not chance wrecking your ride home.
Yeah, exactly. Good question.
All right, excellent. And once again, if you, for the viewers that are viewing the webcast, you're welcome to send in questions. We've only got a couple more minutes left, but I did want to let you know that the address for sending email questions is dlinfochanel@gmail.com. So submit those questions if you like. Oh, it looks like we did get some coming in. So let's take a look at one of them. Actually, this one can be for both of you guys. It basically says, how did you get your job here at NASA? What led you to NASA? Or what experience did you have that helped you?
Well, for me, I actually got interested in it back with Space Academy in Huntsville, or Space Camp for high school. So I actually was in the high school stage.
Oh, okay, at the Marshall Space Flight Center in Alabama? Okay,
exactly.
Excellent.
Yeah, that's actually what kind of piqued my interest. Before that, I was just really interested in aviation, and that kind of got me looking at craft that goes higher and faster, and I got interested in space. So I went to Colorado School of Mines in Golden, Colorado, got a degree in mechanical engineering, right now doing a degree in systems engineering at Stevens Institute, and that's kind of the path that I've been on.
Excellent.
Yeah, I've actually just always been interested in the space program. And my father worked in the space program, so I kind of was around it a little bit growing up. And so, but just even on my own, just always interested in the idea of going into space and doing stuff. So I went off to Texas A&M University and got my bachelor's in mechanical engineering, and came over to NASA after that. And worked for several different contractors. So you were asking about contractors earlier. I've worked for Lockheed and SAIC and Barrios and the United Space Alliance. So I've done several different jobs around here and been able to be a part of several different contractors and do some robotics and spacewalk stuff. So,
were either of you interns or co-ops here at NASA before you actually got your job here?
Yeah, I was actually was a cooperative education student, so that kind of got my foot in the door. And alternate semesters of school with working here full time.
And that's really a great way to do it. You get a little bit of work experience while you're still in college, and then once you graduate, typically it leads to potential job openings.
And it's not just filing papers and things like that.
No.
It's actual work that engineers and scientists are doing here at NASA. You get your hands in it, and you get to experience it and see what it's like to be an engineer or scientist right here.
Matter of fact, the water system, so we have to bring our own water to the MMSCV. So the system that we have to give us water that we can use for drinking and whatever we need was actually partially designed and installed by 2 co-op students.
That is awesome.
And they're doing real work for this.
Excellent. So if you guys want to do that in college, I know you guys will be graduating soon, definitely look into internships at many of the NASA centers. All right, I'm going to take one more from the internet, and then I'll take maybe one more question from the high school, and then we'll conclude our program. Question was, how do you sleep, eat, and bathe? Do the basic hygiene stuff in there. Are there enough facilities in there for you?
There are. So it's a lot like camping. You don't have a shower like you have on Earth. You don't have everything that you would really like. The sleeping in this, there are actually bunks, so we can convert the middle of the cabin. We can clear everything out, and there's some cushions we can sleep on. They're just bunks. There's curtains that go around it to give you a little bit of privacy. You have lights in there, so you kind of sleep like you would in a normal bed. Maybe not the most comfortable normal bed. In a zero gravity environment, you would probably just have a sleeping bag that you would attach to the wall somewhere and just free float.
Yeah, that's an amazing thing. You can sleep on the ceiling, you can sleep on the wall. It doesn't matter when you're up there in a microgravity environment.
Yeah, and a lot of just wiping yourself. You got wipes and wash rags and stuff that you can wet. So you don't get a full shower in there. That's kind of one of the drawbacks to living in there. But again, it's kind of like camping. If you've ever gone on camping somewhere where you're away from active running water, then that's basically what this is like.
Okay, excellent. All right, now I want to conclude the program, maybe taking one or two final questions from Tuoso Midway High School.
Well, one of our students asked what kind of age groups are working there. How young could you be and actually
work? Well, we have even high school interns that come in, so your age. And we also, let's see, I started as a co-op when I was 20. So, anywhere from your age right now, you could get involved in NASA. And I would say probably the majority of the population right now, we've got kind of basically two different ends of the spectrum. We have a lot of very senior folks here at NASA that are nearing their retirement, and we also have a lot of folks that are just starting their careers here. And so there's probably a smaller pool that are kind of in the middle in their 30s and 40s. So, good question.
So we're definitely going to need you guys.
Yep.
Our high school program is called the High School Aerospace Scholars. You can look it up on the nasa.gov website /education, and you'll be able to learn about it, and then also internships and co-ops as well. So definitely get involved, and if you're interested in doing this as a career, definitely come out and see one of the NASA centers. Actually, since you guys are in Corpus, come on up to the Johnson Space Center.
Not too far away.
All right, excellent. Well, that wraps up our program. We're run out of time, but I want to thank you guys there at the high school. We really loved all of your great questions, and for those of you that are watching on the DLN webcast, really appreciate you guys participating. So from everyone here at the Johnson Space Center in the Space Vehicle Mock-Up Facility, Building 9, bye everyone.
See you guys.
Thank you.